I'm not here today, and yet I am here. Isaac, wake up. Riley, I like your shirt. Lane, you should be here today. Okay. While I'm not here, I did think that you could probably do section 9.1 pretty simply if you just follow some instructions. So I'm going to tell you how to do section 9.1. If you want to follow along, it's on page 545 where I'm starting from. Now, section 9.1 deals with translations, and a simple translation is just moving an object from one position to another by sliding it across. So like, there's a pen, I could translate it just by sliding it. Okay? Notice I didn't rotate it. That would be a different translation or transformation. All I did was slide it. So you could go up or down or from side to side or diagonally. All you're doing is sliding things. Okay? Now, according to the book, before the thing is moved, and it could be a pencil, it could be a square, it could be a triangle, but before the object is moved, it's called the pre-image. That's before we slide it. And after we slide it, that's going to be called the image. Okay? So if you turn your books over to page 546, it says identifying a rigid motion. Rigid motions don't change the shape of the object. This is a pen. If I break it, it's not a rigid motion. But if I just slide it from one position to another, it's called a rigid motion. It keeps its size and its shape intact. Problem number 1 there asks if some of these things are rigid motions, and it might have something like a triangle, and we call that the pre-image. And after I've slid it into a new position, I would call that the image. Assuming that these were the same size, does that look like a rigid motion? Answer, yes. It hasn't changed the shape or the size, therefore it's a rigid motion. Now also notice that the pre-image and the image would match up. If this is A, B, and C for the points of the vertices, after it's been translated, we're going to call these points A prime, B prime, and C prime. Notice we put these little marks afterwards, and we call that prime. So A has been translated from its original position into a new position that we call A prime. B has been translated from its original position to a new position, which we call B prime, and C has been moved or translated to a new position that we call C prime. Okay? Original and its image. The pre-image and its image translated or slid to a new position. Okay? Okay. Now when we did that, we noticed, hopefully we noticed that the parts correspond with each other. A corresponds with A prime, and side AB corresponds or was translated into A prime, B prime. Okay? Those parts match up. So on problem number 2, where it says naming images and corresponding parts, notice that we can match these together. What are the other ones we could match up? Think. Hopefully you said, ooh, we could take AC and it would map to, that's right, A prime, C prime. Groovy? Okay. So, problem number 3 says finding the image of a translation, and here's where it gets, it's not complex, but this is the most complex thing we're going to do today. Here's where we get into some notation. Here it says we're going to slide things with a translation called T for translation, and then we put these little brackets and it tells us where it's going. What this says is we're going to slide in the left direction, because this first one represents the x's and the second number represents the y's, so we're going to go down. So this says, hey, translate whatever object you have to the left by 2 in the negative x direction by 2, and then down in the negative y direction by 5. You see? So if I took, let's make a square. And my square lives here, we'll call it SQAR, scare. That's my square scare. And I'm going to translate it -2, -5. So I'm going to go in the x direction by -2, 1, 2, and down by 5, 1, 2, 3, 4, 5. So it's going to change, right? How does that work? Well, if I took S and I slid it to the left by 1, 2 in the negative x direction, and then in the negative y direction by 5, it's going to go down by 5, 1, 2, 3, 4, 5, and so S prime lives there. Let's do that again. Starting with R, we're going to slide it to the left by 2, 1, 2, and down by 5, 1, 2, 3, 4, 5. There's R prime. Let's do it with Q. It goes to the left by 2 and down by 5. 1, 2, 3, 4, 5. Here's Q prime. Okay? And the last one, A, gets slid where? Yep, to the left by 2 and down by 5. 1, 2, 3, 4, 5. And so that is A prime. Here's my new image. Scar prime. Make sense? Groovy. If you take a look at problem number 4, I'm going to slide my book over because I don't want to draw this. If you take a look at problem number 4 in the book, zoom in on that. It says, hey, after we focus, it says, hey, what rule would describe the translation that maps PQRS onto P prime, Q prime, R prime, S prime? Well, notice this is the pre-image, right? It's PQRS, and it's going to be mapped over here to P prime, Q prime, R prime, S prime. So all we have to do is figure out how far it went in the X direction and how far it went in the Y direction. So let's count. From P to get over to P prime, I have to go over by 1, 2, 3, 4, 5, 6, 7, 8. Right? Don't write in your books, but I know that in the X direction I went 8. And in the Y direction, after I got here, I went down by 1, 2. I went in the negative Y direction by -2. So if I'm describing that translation, I would write it as a translation, right, that went 8 in the X direction to the right by 8, and down, or in the negative Y direction by 2, and that translation is 8, -2. Okay? Okay. Now, the last part of this lesson says that you could compose. In other words, you could put some of these together. In other words, you could say, ooh, what if you had a translation of 8, -2, and then you followed it with another translation where you said, I don't know, let's go -2 and +5. Right? So could you compose these two together? Yeah, you could do what we did up here. We'd say, all right, each of these points is going to move in a certain direction, and then I'd do the next one and move each point from there into another direction. But there's a shortcut to this. When you're composing them, you can just add your x values together. So you go, this combination, if I did both of these, if I moved 8 in the x direction and then down 2 in the y, and then I moved negative 2 in the x direction, and then 5 in the y, I could just add these together and say, 8 minus 2 means really I'm only moving 6 in the x direction, and when I take negative 2 and add it to 5, it gets 3 in the y direction, so my combination is this. That's my final one, and we could compose 2, 3, 4, 5 of these together. We just add all our x's together, write it down, add all the y's together, and write that down, and that becomes the full translation. Okay? All right. Your homework problems are on my planner, so write that down on your paper. Good luck, and we'll see you next week. Thanks, guys.